Suppose I took out this folded piece of paper. It's actually a flimsy old paper plate. And somebody asked me some questions like, what's the sine of 4 pi over 3 radians? And I said, negative square root of 3 over 2. Or they said, what's the cosine of 120 degrees? And I said, negative 1/2. Or they said, what's the cosine of pi over 3 radians? And I said, 1/2. Or what's the sine of 270 degrees? And I said, negative 1. What I'm doing is looking at these numbers on a unit circle that I wrote on this flimsy piece of paper plate. This is called a piPlate, and I learned how to make one of these years ago at a math workshop. And today I'm going to show you how to make one. It's one of the most useful tools you'll have when it comes to working with a unit circle. You can read right off of it the sine and cosine for different angles, both in radians and degrees, and you can convert easily from degrees to radians as well. If you haven't already, please take a second right now and subscribe to this channel. And thank you for watching. And we'll get started now on making our piPlate on MathCat. 3, 2, 1. Let's start our piPlate project with a list of materials that you'll need. I have a set of pens. You could use colored pencils or colored pens. To tell you the truth, colored pencils would probably make a little bit neater piPlate. You'll need a protractor. You'll need a ruler. You'll need a single piece of paper and a push pin or a tack, and I'll show you what that's used for. You may or may not need that. And then your paper plates. And I'm using this fluted kind that has a small inner circle, and it turns out that this small inscribed circle is actually a little smaller than I like because I can't write inside it very neatly. So I'm going to make my circle a little bit bigger. There are different kinds of plates with a little bit larger inscribed circle. You'll find that after you make one piPlate, you could make another one in under 10 minutes once you go through the instructions. I have several here. The nice thing about this kind of flimsy paper plate is that you can fold it up, and then you can put it inside a math book or calculator case or even in your pocket. So I prefer the more flimsy kind of paper, but you could make a stiffer one and just use it on your desktop, for example. So let's start constructing the piPlate. The first thing we'll have to do is find the center of the plate, and for that I use my sheet of paper. And the way you do it is to put the corner of a sheet of paper on the edge of the plate. I'm going to pick one color here and mark where the edge of the paper touches the edge of the plate with one color, and that will give you a diameter. And then take your ruler, and I'm going to use inches. You can use centimeters. Connect the two dots that you've made and measure your plate. I have 9 1/8 inches, and I could just scribe a line from side to side, but that's going to be a line that we don't need later. So I'm just going to take my 9 1/8 and find halfway. So half of 9 is 4 1/2 plus a 1/16, and I'm just going to put a dot at that point. Then I'm going to find another diameter. In fact, I'm going to take my paper now and lay it right on one of my first dots on the edge of the plate, and it will more or less give me a right angle to the first line that I drew. So now I'm going to mark with a different color pen so I can tell the difference, and mark where it touches the plate. Take my ruler again and make sure I have 9 1/8 inches. Half of 9 is 4 1/2 plus a 1/16 and a dot. And my dots don't exactly line up, but I'm pretty close. Now here's where the push pin comes in. If you want to make a circle around a line that's already on the plate, what you can do, and this only if you're allowed to make a little pinprick in your desk, push the pin right through the plate into the desk so that the plate will spin on the center. And I'm going to retract my pen because I'm not going to use this circle, but you can hold your pen on a line on the plate and then slowly rotate the plate and scribe a nice circle. You could use this method anywhere on the plate, but I'm going to use my protractor to make my circle. So that's what the push pin is for. I'm going to use my black pen and my protractor to make my circle. And I did this before, and I noticed that the protractor was just slightly larger than the inscribed line on my plate, and that was the size that I wanted. So my protractor, 0 and 1/80, are a little bit up from the edge of the protractor, so I don't want to use this edge as the diameter. And there's a little hole in my protractor where you put the center. So using that hole for my center, I'm going to just scribe a little line out here by 180 degrees and back here at 0 degrees. And now I'm going to just trace around my protractor. And then I can rotate the plate around, find the center again, line it up with the lines that I made, and go around the protractor again. So I'm happy with that size circle. It's slightly larger than the circle that was already inscribed on the plate. So we also want to find 90 degrees on our circle in both directions. So I'm going to line up my 0 and my 180 degrees and just put a little line up by the 90. I'm still using the black pen. I'm going to spin the plate around, line up my 0 and 180 degrees in the center, and mark 90 degrees again. Now I'm going to start labeling. I'm going to pick the right hand side and label it 0 degrees slash 360 degrees, because if you go all the way around the circle, that's 360 degrees. And I'm also going to mark in radians, 0 radians slash, and if you go all the way around the circle, it's 2 pi times the radius of the circle. But this is a unit circle where the radius is equal to 1, so 2 pi r, where r equals 1, is simply 2 pi. So I'm going to label this 2 pi radians. So now that I have my 0 point, I'm going to connect my lines using still the black pen. And you can use your own coloring scheme after you've made one of these. But I want my 2 major lines to be black, the same color as the circle. And now we can label each point. This is 90 degrees, 1/4 of the way around the circle. 1/4 of 360 degrees is 90 degrees. And 1/4 of 2 pi is 2 pi over 4, or pi over 2. So it's pi over 2 in radians. Next we go halfway around the circle. Half of 360 degrees is 180 degrees. And 1/2 of 2 pi times 1/2 is pi. So it's pi radians. Then we're going to go 3/4 of the way around the circle. And 3/4 of 360 degrees is 270 degrees. And 3/4 times 2 pi, 3 times 2 is 6, divided by 4 is 6/4 pi. And if you reduce that, it would be 3/2 pi, or 3 pi over 2 in radians. Next I'm going to go with my blue pen, and we're going to mark 45 degrees around the circle. Line up my center and my 0 and 180. Now my protractor has 45 degrees from either side, so I can just go up 45 on this side with a little mark, and up 45 degrees on this side with a little mark. Otherwise it's 45 degrees, and then to the next one's 135 degrees. And then I spin the plate around and do it again. Find the center, come up 45 degrees, and 135 degrees. I'm going to straighten the circle back out. My preference is to connect these lines with dotted lines, but it's up to you if you want to use a dotted line or a solid line. So I'm going to make a dotted line in blue, and it's to the center from every direction, but I'm just going to keep right on going to the other side and out to my other mark, and then this way with a dotted line. And if you notice, these are 1/8 of the way around the circle. I've now divided the circle into 8 parts. So 1/8 of 360 degrees is 45 degrees, and 1/8 of 2 pi is 2 pi over 8, or pi over 4 radians. This one's already marked. We'll go over here. We're at 135 degrees, and we're 3/8 of the way around the circle. So 3/8 times 2 pi is 6/8 pi. Reduce that is 3 pi over 4. Now we'll come down here, and we're 5/8 of the way around the circle, and 5/8 times 360 is 225 degrees, and 5/8 times 2 pi is 10/8 pi, or 5 pi over 4. And you'll see a pattern developing. All of these are going to be over 4 in radians. Finally, we're 7/8 of the way around the circle. 7/8 of 360 is 315 degrees, and 7/8 times 2 pi is 14/8, or 7 pi over 4. And now that we've got our 45 degree angles marked, we can name our quadrants. Right off the end of the 45 degree line, this is quadrant 1. I'm going to put a big Roman numeral 1. And off of the second one, I'm going to put Roman numeral 2 for quadrant 2. And down here off the third one, I'm going to put Roman numeral 3 for quadrant 3. And over here, I'm going to put Roman numeral 4 for quadrant 4. Now I want to mark 30 degrees around the circle. So I want to use my protractor, and I'm going to use a green pen. Line up our center and our marks. And with my protractor, I can come up 30 degrees on this side and up 30 degrees on this side. If you have just one scale, it's 30 degrees on this side and 150 degrees over here. And then spin your plate around and do it again. And we'll come up 30 degrees on this side and 150 degrees over here. And connect our dots. And I'm going to extend this line a little farther out beyond the circle so that when I write the numbers they don't overlap with the numbers I just wrote. Through the center, and I'm going to extend it beyond the circle. And then this way, through the center, and extend it beyond the circle, and back this way beyond the circle, to the center. So this first one I'm going to label 30 degrees, and 30 goes into 360 12 times, so I'm 1/12 of the way around the circle. 2 pi over 12, or pi over 6, radians, pi over 6. And in fact, all of these measurements will be over 6. Over here, halfway would be 6/12 of the way around, so this is 5/12. 5/12 of 360 is 150 degrees. I'm going to write out here on the end, 150 degrees. And 5/12 times 2 pi is 10/12, or 5 pi over 6 radians. 5 pi over 6. So this would be 6/12, 7/12 of the way around the circle. In degrees, that's 210 degrees, and 7/12 times 2 pi is 14/12. That's 7 pi over 6 in radians. And finally, we're 11/12 of the way around the circle, which is 330 degrees, and you can multiply 11/12 times 360, and 11/12 times 2 pi is 22/12, or 11 pi over 6. And the last marking I want to show are the 60 degrees. So I'm going to change colors again, this time to red, and I'm going to mark 60 degrees. So I'm going to come up 60 degrees, and over here it's either 60 degrees up from 180 or 120 degrees from the origin. Spin the plate around, come up 60 degrees and 120 degrees, and we'll connect our lines. Make sure it goes through the center. I'm going to extend this line out beyond the circle as well. So let's label our 60 degrees in quadrant 1. And 60 into 360 is 1/6 of the way around the circle. So 1/6 times 2 pi is pi over 3 in radians. And in fact, all of our markings will be over 3 this time. We come over to this quadrant, and it's 120 degrees. And we are 2/6 of the way around the circle. And 2/6 times 2 pi is 4/6, or 2 pi over 3. Then we're 4/6 of the way around the circle, and you can multiply 4/6 times 360 degrees to get 240 degrees, and 4/6 times 2 pi is 8/6, or 4 pi over 3 in radians. And then we are 5/6 of the way around the circle, and 5/6 times 360 is 300 degrees, and 5/6 times 2 pi is 10/6, or 5 pi over 3 in radians. Now these next lines I'm going to add are for clarity, and I'm going to do them in the first quadrant only, and you may want to omit them in a later version of your piPlate. I'm using my single piece of paper again, and I'm going to draw a line. I'm going to start here where the 60 degree line crosses the circle, put my right angle on 0 degrees, and draw a line straight down, dotted line, till I hit 0 degrees. And then I'm just going to kind of freehand a little red dotted line above the black line. And I'm going to label this X and Y somewhere in the middle. Next I'm going to do the same thing with my 45 degree line, which I drew in blue, so I have my blue pen back out. Use my sheet of paper and the right angle up from 0 until I hit where the 45 degree line crosses the circle, and draw a dotted line straight down. And kind of freehand a blue line over above the black line. And this I'm going to label X and Y again. And now I'm going to do the same thing for the 30 degree line, which is green. So using my green pen and a sheet of paper, line up the sheet of paper where the green line touches the circle and come straight down. And maybe just a little hint of green here. Call this X and this Y. Now I'm going to put a key on my circle over here on the side near the origin. I'm going to say X comma Y, like an ordered pair. And then I'm going to write this, cos comma sine. We start here at the center. And let's take the red lines. The cosine of this angle. Well, here's our right angle up from our 0 degrees. So that makes this the hypotenuse. Well, what's this line? The radius of the circle. And cosine is adjacent over the hypotenuse. So we have X over r, the hypotenuse. But what is r in a unit circle? R is 1. So we have cosine of this angle is x over 1, or x. So cosine is going to correspond to our x value. In the same way, our sine is the opposite over hypotenuse. So if we have sine equals y over r equals 1, sine equals y over 1, or sine equals the y value. Now look what happens with the x value. This is the x value for the red line, this is the x value for the blue line, and this is the x value for the green line. But the x value for our black line goes all the way out to the edge of the circle, which is 1. As you go up, your cosine is whatever the value of x is, and your sine is whatever the value of y is, until you get to here, and your cosine is 0, because x is 0, and y is 1. So what are these in-between values? Well, it turns out there are only 3 values we need to know for 30 degrees, 45 degrees, and 60 degrees. And they are 1/2, square root of 2 over 2, and square root of 3 over 2. And I've written these in increasing order. 1/2 is the smallest, square root of 2 is about 1.41 over 2, and square root of 3 is about 1.73 over 2. So this is 1 over 2, 1.41 over 2, 1.73 over 2. Increasing order. Keep that in mind, and we're going to label the values for the cosine and the sine along the circle. So I'm just going to give you the values for the first quadrant, and then we'll reflect those values into the other quadrant. So this is the largest x value, so the cosine is going to be the largest number here. It's going to be square root of 3 over 2, and I'll just give that to you. And y is going to get bigger as we go up the circle. So here the smallest value for y out of the 3 was 1/2. And we're in quadrant 1, so both the cosine and the sine are positive. X is positive this way, y is positive this way. Let's go up to 45 degrees. We're halfway. X and y are the same. So your cosine is square root of 2 over 2, and your sine is also square root of 2 over 2. And in the first quadrant, they're both positive. As we go up the circle, x is now the smallest value, which is 1/2, and y is the largest value, which is square root of 3 over 2. And in the first quadrant, they're both positive. Here at 90 degrees, x is 0, and y is the radius, or 1. In fact, I could have written here at the beginning, the cosine is 1, and the sine is 0, because y is 0 out here. Now let's go back down the circle. We have y being the largest value and x being the smallest value, but we're in quadrant 2. Y is still positive. We're still going up, but now we're going backwards. We're going to the left. So x is now negative. So it's going to be negative 1/2, positive square root of 3 over 2. Cosine is negative in the second quadrant, but the sine is positive. Let's go back down the circle a little farther. Our values are equal, but the cosine is negative. So it's going to be negative square root of 2 over 2 for the cosine, and positive square root of 2 over 2 for the sine. And out at 150 degrees, x is the largest, square root of 3 over 2, but it's negative. So it's negative square root of 3 over 2, and the sine is 1/2, and it's still positive. Out here at 180 degrees, y is 0, and x is negative 1. The cosine of 180 degrees is negative 1, and the sine is 0. Now let's reflect from quadrant 2 down to quadrant 3. So we have negative square root of 3 over 2 for x, and negative 1/2 for y, the smallest value for y. Down here we have the same value, but they're both negative. Negative square root of 2 over 2 for x, negative square root of 2 over 2 for y. Here x is small and y is the largest, so it's a negative 1/2 for x, negative square root of 3 over 2 for y. Now we're coming back on this side of 0, positive x, negative y. So we're going to have 1/2 for x, and it's going to be positive, and negative square root of 3 over 2 for y. Here, positive square root of 2 over 2 for x, and negative square root of 2 over 2 for y. Here, x is positive, square root of 3 over 2 for x, and negative 1/2 for y. So just looking at this, what we've just done is find the values of the cosine and the sine at any angle, and the angle could be in radians or degrees. So if I said find the sine of 2 pi over 3, sine of 2 pi over 3, that's this angle, and the sine is square root of 3 over 2. Find the cosine of 240 degrees. 240 degrees is here, the x value is negative 1/2, so cosine of 240 degrees is negative 1/2, and that's how you read off from the piPlate. You can use the back of your piPlate to write down any formulas that you want to have. Area of a circle, for example, is pi r squared. Circumference of a circle is pi times d, or 2 pi r, because d is twice the radius. You could write down 1 degree is pi over 180 degrees in radians, or 1 radian is 180 degrees over pi, and anything else that you need to have memorized. The last thing I do is fold my piPlate with this flimsy paper. Can't always do this depending on what you've used, on the 2-axis. And then fold it over. And you now have something that you can put in your book, put in your calculator case, put in your pocket. You could fold it over again. You could take it out, unfold it, and you've got all the information right here at your fingertips. And that's how you make the piPlate, and that's how you use the piPlate.